On June 28th, the U.S. Navy and Huntington Ingalls Industries, HII, christened the future USS Jeremiah Denton, DDG 129, during a ceremony in Pascagoula, Mississippi. This marks the third Flight III Arleigh Burke-class guided missile destroyer to be constructed at the shipyard. The vessel is named in honor of the late Rear Admiral Jeremiah Denton, Jr., a U.S. Navy aviator and former U.S. Senator. A decorated Vietnam War veteran, Denton was awarded the Navy Cross for his extraordinary heroism as a prisoner of war. He served 34 years in the Navy, including 8 years in captivity during the Vietnam conflict. Ingalls Shipbuilding President Blanchette said, "When we christen a ship, we celebrate a joint mission with our Navy industry partners, one that connects the work we do here in Pascagoula to the safety and security of our nation and the free world." Flight III Arleigh Burke-class destroyers represent the next generation of surface combatants and incorporate a number of design modifications that collectively provide significantly enhanced capability. In this video, Defense Updates analyzes what makes USS Jeremiah Denton DDG 129 incredibly mighty. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The AN SPY-6 is an active electronically scanned array 3D radar developed for the United States Navy. SPY-6, also known as the Air and Missile Defense Radar, AMDR, has scalable and modular radar arrays that reduce cost and sustainment needs while meeting the mission requirements of 7 classes of ships, which include Flight III Arleigh Burke-class destroyers. Variants are also developed for retrofitting Flight IIA Arleigh Burkes and for installation aboard Constellation-class frigates, Gerald R. Ford-class aircraft carriers, and San Antonio-class amphibious transport docks. AN SPY-6 V1 variant is meant for the Flight III Arleigh Burke-class destroyer and will provide integrated air and missile defense. The SPY-6 radars integrated into the AEGIS combat system can help defend against ballistic missiles, cruise missiles, hostile aircraft, and surface ships simultaneously and provide several advantages over legacy radars, including greater detection range, increased sensitivity, and more accurate discrimination. It is a 4-sided phased array radar, each with 37 radar modular assemblies, RMAs. It is estimated to have a 15 decibel sensitivity improvement compared to the previous generation AN SPY-1 radar, or capable of detecting targets half the size at twice the distance. The SPY-6 system consists of 2 primary radars and a radar suite controller, RSC, to coordinate the sensors. An S-band radar is to provide volume search, tracking, ballistic missile defense discrimination, and missile communications, while the X-band radar is to provide horizon search, precision tracking, missile communication, and terminal illumination of targets. The S-band and X-band sensors will also share functionality, including radar navigation, periscope detection, and missile guidance and communication. SPY-6 is intended as a scalable system, with each sensor array assembled from radar modular assemblies, self-contained radar modules. The transmit-receive modules use new gallium nitride, GaN, semiconductor technology, allowing for a higher power density than the previous gallium arsenide radar modules. The new radar will require twice the electrical power as the previous generation, while generating over 35 times as much radar power. The SPY-6 was not originally designed to perform electronic attacks, but it may have the capability to do so using its AESA antenna. SPY-6 V1 variant simultaneously defends against ballistic missiles, hypersonic missiles, cruise missiles, anti-surface and anti-air threats, as well as jamming, clutter, and electronic warfare. It will enable Arleigh Burke warships to shoot down incoming threats by using missiles like SM-6 more reliably. Flights 1 and 2 are equipped with 3 Allison 501-K34 generators, each generating 2,500 kilowatts, 3,400 horsepower, while Flight II-A is fitted with 3 Allison 501K34 generators, each putting out 3,000 kilowatts, 4,000 horsepower. Flight III takes a substantial leap in this area. It's actually a 33.33% increase. It has 3 Rolls-Royce MT-5S HE plus generators that produce 4,000 kilowatts, 5,400 horsepower each. This extra power could be used for directed energy weapons in the future, apart from supporting the more powerful radar. Viewers may note that earlier this year, the U.S. Navy confirmed that the Arleigh Burke-class destroyer, USS Preble, successfully tested its high-energy laser with integrated optical dazzler and surveillance Helios system, taking down an aerial target drone. Helios, named after the Greek sun god, is a multi-mission system that combines high-energy laser power with optical dazzler and surveillance capabilities. Aboard the warship, Helios is mounted on the main forward pedestal, a position previously occupied by the Mark 15 Phalanx close-in weapon system. Helios can be configured to have a power of 60 to 120 kilowatts. The U.S. military is also working on many other types of laser weapons apart from Helios, all of which will depend on the ship's onboard power to drive them. Technically, Flight III is capable of accommodating a high-power laser weapon, such as Lockheed Martin's High-Energy Laser Scaling Initiative, HELSI, which is slated to have a power rating of 500 kilowatts. The AEGIS weapon system has long been a pivotal element of the U.S. Navy's surface combat capabilities. Developed primarily by Lockheed Martin, it is a centralized automated command and control, C2, and weapons control platform designed as an end-to-end solution. It can manage the whole cycle: detection, tracking, and interception. That is the full kill chain. The latest iteration, Baseline 10, marks a significant evolution, integrating advanced radar technology and software architecture to address modern and future naval warfare demands. AEGIS weapon system Baseline 10 software is based on a new architecture. Lockheed Martin states that this will increase the speed at which new upgrades can be made to the system. Lockheed aims to leverage this innovative architecture to significantly reduce the usual timeline for delivering a new capability to the fleet. It will work with the Common Source Library, CSL, that will combine all surface Navy capabilities into a single software repository. Baseline 10 is anticipated to enable the team to incorporate new capabilities into the library within 3 to 4 weeks, rather than the extended period of 3 to 4 months in some instances. The company reports that it has been increasingly automating tests to expedite the verification of software updates, referring to Baseline 10 as the most comprehensive evolution of an AEGIS baseline to date.